How's it going, cool cats and kittens? It's Miss Fishman coming at you live from YouTube, except it's not live, it's pre-recorded. Let's just jump back into it. We're going to be starting systems of equations. We're going to be looking at this new form, this new exciting thing. We're used to just linear equations, we're just our one little line. Systems is, don't freak out, the exact same thing, you're just doing two. We've already done parallel and perpendicular lines. I know it was a while ago, but you have actually already had some exposure to this, so I think you're going to love it. I'm going to write this out for you. You're not expected to write this down. You don't have your notebooks unless you took it home with you, and I won't be able to get you these foldables. So you can just watch along, have this as a reference to go back to, okay? Because these are kind of like your online notes with me in them. So exciting. So a system, it's going to be a little slow. Sorry about that. A system of equations is one or more equations. A solution to a system is the point. Sometimes you can have multiple solutions, just to let you know, but we're just going to look at one solution where the graphs touch. That point makes all equations true. So a system of equations is one or more equations. A solution to the system is the point where the graphs touch. I know that looks like two words, it's one. That point makes all equations true. So let's start by looking at intersecting lines. Let's say we are over here. So here's one line, beautifully drawn. Oh, I should be using my fancy tools. Here's another line, actually beautifully drawn. They have one solution, right? One point, let me get reread actually, one point at which they touch. So that's the solution. Next we have parallel lines. So let's draw, let me make sure I'm on my line, yes. Let's draw one line right here. And let's get blue. And let's draw another beautiful straight line with blue, please. Right here. Here we go. Notice how, like we talked about, they're never going to touch, so there's going to be no solution. So I want you to write, let's see if I can just type this out. No solution. Right here, we're going to write one solution. Should I have been doing this the whole time? Yes. Am I going to stop recording to do it again? No. Now, let's say we have the exact same line. Draw right there. It might be a little bit harder to do this, but that's okay. You're going to draw the exact same line over it, right? They're literally on top of each other like this till the end of time, from the beginning of time. So there's infinite many solutions. So you can just put infinite solutions, infinitely many solutions, whatever your heart says, right? So let's move on to an example. We have these two graphs. Oh, I'm in the way. Let me scooch over. Scooch, scooch. That's never going to get old. So we are going to start basically by graphing one line, and then I'm going to blow your mind graphing the second line. It's not too bad. You're going to graph them on top of each other. So we have -1. That's our y-intercept. That's what we're anchoring with. Then we have +2. So it's going to be up 1, 2. To the right 1 with my ability to draw a line. Let me, oh no, that's not good. I'm going to redo that. I'm going to be very sad, I guess. Maybe this technology is not all it's cracked up to be. Oh, you know what I could do? Ha ha ha. I'm unstoppable. So, good enough. Next we have our second line. Like I said, you're basically just drawing two lines, which you can already do. We're starting at a +7, and this is a negative, so we're going to go down 2, and to the right 1. I'm going to draw our line, which is blue this time, for fanciness. I'm only going to go over one example of this with you, because then I'm going to teach you how to do it. Well, you don't have access to a calculator, so I'm going to teach you how to do it a different way. little bit easier actually than the calculator in what I'm doing. So it's hard when you're doing it by hand to get it perfect, but it should look something like this. So how many solutions do we have? Just one, and it's right here. And you might be like zooming in on it with your eyes, like looking really close and being like, Miss, I can't see where those cross, that's really confusing. Theoretically, we would be doing this by hand, so we'd have a little bit more wiggle room, and then we'd be doing it on the calculator. You don't have access to calculators, so I'm going to show you right here how to do it. This is Desmos, DESMOS.com. You type it in, you have this lovely graph. You are very lucky that you get access to it, and we're going to type in our equations, which I've already forgotten. Y equals 2x minus 1. What color did I make it? I made it green, and it's green. Wow. Y equals, I think it was negative 2x plus 7. So I'm literally just typing in these calculators. I'm going to change it to make it the same color. Hold on. Okay. I literally just typed in the equations as given to me, right? Y is by itself, so we're good to go. And the really fancy thing about Desmos is you can just kind of click and hover over it, and it'll give you the solution. So we have one solution, and that solution is 2, 3. You can use Desmos to graph for our activity just because I know a lot of you don't have calculators. Well, the Casio calculators. You have phone calculators. So please feel free to use Desmos. I'm going to link it again. It's also in our website, so you can use the website if you'd like. But I just wanted to let you know, you can use Desmos. This is how you graph systems of equations. This is all we're going to be doing this week, is reviewing graphs and systems of equations. If I feel like we need a little bit more review, I might post something, but this is all I'm planning. So good luck, guys. Stay safe. Reach out if you need anything. You know my phone number. You know my email. Bye.